Hi. So first, I'm just going to introduce myself. I'm Ivan Puri. I'm the head of non-technical operations in Team Radeon. So today we're going to be discussing a little bit about your like career journey, how we can talk to you about your connection to STEM racing, and we'll have a few small little segments later on. So Raj, could you introduce yourself as
Yeah,
well?
I'm
And
Viraj
after that,
Shroff.
just a
I'm the
quick.
sponsorship manager of Team Radeon. And yeah, so
Awesome.
to begin with, can you tell us about yourself and introduce yourself, please?
Awesome. So thank you for having me. I'm Ritvick. I work with Encardio as the product and technology lead. And I've basically spent the last 3 years evolving from more of a civil engineer into an electrical engineer. Now I work a lot into data science and machine learning products. So we're a 60-year-old organization and we work in the monitoring of infrastructure assets, so like dams, bridges, tunnels, mines, etc. And we make the sensors for it, IoT for it, and then all the software, data analysis, data integration. So in a very similar way, you have a lot of sensors or data analysis you do on your cars or STEM racing. We basically do that for infrastructure assets from the end-to-end solution.
So, can you tell us a little
That's
bit
pretty
more
cool.
about your early interest in engineering and technology?
Yeah, so I think as a kid, like same way you guys have probably grown up, we've always liked the math side of things, the physics side of things, and then that slowly evolves into doing robotics in school. And at my time, I did a lot of work with like EV3 because that was the end thing. Now it's of course evolved to a lot more that you can do at that time. And then also used to visit like the office a lot as a kid growing up. And I worked a lot, like everything was about sensors and monitoring. So I think that also sparked my interest. And then I went to college and I saw a lot of my friends in civil engineering, what I studied, but I also had a lot of friends in computer science, electrical engineering, mechanical engineering, making weird robots. Some of them were also in Formula racing, either Formula E racing or normal at the college level. So they used to make those cars, they used to go check them out when they used to be testing and hear all the stories of like various developments that they were doing, and also worked on like canoe making. So I had a concrete canoe team. So same thing as you guys do with cars, we made canoes out of concrete. And where you guys look at aerodynamics or like wind tunneling or like different methodologies, we used to look at the strength of concrete to sit two humans in a race. So very similar. So that's what sparked my interest into like solving problems that can benefit humans and the world.
That's great. Thank you for telling us that. Next, we're going to talk a little bit about like how we can connect you to STEM racing. So first, let's talk about the importance of engineering fundamentals in any engineering competition or anything like that.
So I feel like without fundamentals, you can't really do anything. And today, like with the tools we have, whether it's as basic as YouTube to like learn something, or like ChatGPT or Cloud Code or Kimi, whatever you use to like model things and even like build workflows, like you need to have very strong foundations to be able to build upon any of the technologies that you're working on. Because if you don't understand what the one plus one is two, you can't trust an AI to write it for you and make sure it's doing it right or anything. So, for any engineering problem, starting on paper, understanding how what we're trying to solve and going down to first principles and saying, okay, we're trying to build this product or this car or this sensor, whatever it is. These are the
Right.
things that we know. These are the five things that we need to get done. What is the limiting factor? Let's solve the limiting factor and apply genuine iterations and then fit into a loop of this is the issue we've detected. This is how we're containing this issue. This is how we've learned from this gap. This is how we're adapting it into the new product. And then we do that same loop. So the fastest we can do that loop of like detect, contain, learn, adapt. I got this from Pascal Finet, one of his books, and he's a mentor. So that really helps us build much faster, keeping the fundamentals in mind.
And
Right. Thank you for telling us that.
that's really inspiring, yes. And what would you say is your favorite emerging technology in recent times?
in recent times, it's honestly been what they've done with Cloud Cowork because it saves like 90% of my time because I don't code properly at all. So for a non-coder to be able to like build connectors to like n8n and like my GitHub or even like the AWS Argo flows that we do and automate 90% of the work I do day to day, I love it because they've actually taken a complex engineering problem that Anthropic had to improve coding, to train their models faster, translated it into a way that non-coders can do their work. So I think that's my most like interesting tool. And the second one is a lot on edge processing, on microcontrollers, and also on processors. That the amount of compute we can even run and analysis we can do on the edge device itself before sending the data to a cloud processing center it's has tripled, and the cost of those devices have also gone down tremendously. So that's my second favorite side in the hardware because we can do a lot more with a hardware on low power mode than we could 10 years ago and integrate the whole solution.
You also previously mentioned IoT and sensors. So, how would you put IoT in simple words for our viewers here?
So IoT is the Internet of Things. In simple words, it's okay, simplest word is you have to send a message to someone, right? And there's three of us on the call, and Viraj could be a sensor to tell you the temperature, Vivan could be a sensor to tell you humidity, I could be the burglar alarm to make sure no one's opening the door. So it's like a door opening sensor. So the whole purpose of like IoT is really the first fundamental thing is what are you measuring or what action are you trying to take with that device and how you send that message. So in the same way you could send that message through a postman with a letter or through email or through text message or through WhatsApp, there's various ways you can communicate to the internet from that device, either directly through the device or you can use a master gateway which can connect to multiple devices and send those messages and then send those messages to the end user to take an action. So the same way you used to send a letter through a postman to a destination, we send a message from a sensor to a gateway to a cloud environment to be able to synthesize this in a wired or wireless environment. And now it's becoming very, very wireless as well through Bluetooth, radio frequency, whatever the tool is. I hope that made sense.
Yes.
Yeah,
Okay,
thank you for that. Next, I want to talk a little bit about like how we engineer for impact, like how we connect engineering to sustainability. So, my question is, how do we show sustainability through engineering?
So I think at least for us, the purpose of our organization is Janit, which my granddad and our chairman started, and whatever we build has to be for the good of humanity, and whatever product you build has to have some impact on some community. So you don't always have to build a product that directly does sustainability, but the way you build your ecosystem, the way you enable your community to work around that product is very, very critical. So the materials you use in the product, for example, the energy you're using, solar, you're using recyclable batteries, simple things like that. If you're becoming a larger scale organization, what are the protocols you're doing in your factories, for example, with rainwater harvesting? What is the awareness you're giving to your people in terms of something as simple as using reusable cups instead of plastic water bottles in the office? So, beyond just the product, because at the end of the day, the product could be literally a cloud-based software where you're relying on AWS or Azure or whatever, Superbase today to host your model, but it's the people in the community to engage in sustainability that matters a lot. And if you can do it through a product, through materials, through design, through even digital carbon credit footprint, whatever those new things are coming, that's a win-win.
Thank you. So now we have just one short little rapid fire round. Would you like to do that?
Okay, let's do it.
Yeah. Okay. So firstly, the first question is AI or human intuition. What would you choose?
Depends on the task today. It's rapid fire, still human intuition in 2026 May.
Right.
What would you say is your favorite gadget?
I still like my iPhone, I guess.
Next, what would you call smart cities in one word?
Like one word, hashtag not there yet. I guess like it's not developed to that smartness yet.
Formula E
Next,
or Formula
what
1?
Any day, Formula One.
Yeah, next, what would be your dream engineering project? This is the last one.
I think to be able to find a way for humans to be like multi-planetary, explore like the end of like where we really can take life to, and being a part of that mission to really see where we evolve as a species in the long run beyond Earth while protecting Earth and our consciousness. I think that's the dream.
Thank you so much for being here with us today. Thank you for giving us all of your knowledge that we could have asked for today. We really appreciate it. Thank you for being here.
Thank you so much, and you guys are going to do well. So keep doing what you're doing and good luck.
Thank you.
Let's
Thank you.
win
Appreciate
this.
it.